All right, so a little day two recap for our Can We Build a Better Can thing. Some periodic table review type things, right? We should have spent a little more time with our periodic table. Um, if we look at that, does this link work if I don't hit present? Nope, I've got to hit present. So a quick look at our periodic table and some reminders on that, right? So when we see this one looks a little different than yours, but it's got the same kind of stuff, right? This number up at the top is the atomic number. That's the number of protons. The protons are what define the atom. So sodium is sodium because it has 11 protons, right? We see this 11 right here. That's the 11 protons that make sodium sodium. The symbol is there. Na is the symbol for sodium. That's because in the Latin and Europe, actually, they don't call it sodium. They call it natrium, right? Same thing. Potassium is kalium in Europe. That's where the K comes from. It's not vitamin K. I've had some kids think that potassium was vitamin K. But anyway, then you've got these average atomic mass down here. And that average atomic mass comes from the average of all the isotopes. Right, so each individual isotope has 11 protons. That's why they're sodium, but the different versions of sodium have different numbers of neutrons, right? So you can see since the protons and the neutrons add up to the mass, we can see most sodium has a mass of about 23. So most sodium has 11 protons and 12 neutrons, right? Because 11 plus 12 is 23. But not all of it does. Some of it has less. Some of it can have more. Some elements only have one isotope, like aluminum only has one isotope, but then others have like 9 isotopes. I think chromium and silver both have like 9 to 11 different stable isotopes and stuff, right? Anyway, on the periodic table here, our rows are the layers of electrons. So this periodic table actually shows this 2, 8, 1, right? That's like the layer. In the first layer, there's 2 electrons. In the second layer, there's 8. In the third layer, there's 1, right? So we can go here and we can kind of get that quick layers of electron stuff. So the rows are the layers of electrons. The columns are the numbers of valence electrons. And we need those valence electrons because that's going to dictate what ions form and then how many bonds they form if they don't form ions, if they're more of a covalent type thing. So we look at this isotope notation. We see carbon 12. So to do carbon 12, we would write a C. Oh, shoot, I can't draw on this screen. Well, let's make this big for a quick second. Oh, no, I made it go away. Well, let's see if I can do a pen here. I don't want a black pen. I'm on a black screen. So if we go blue, so it's carbon 12 that we'd write that as we'd write a C. And then if you look in your periodic chart, you can see that carbon has 6 protons. So we'd put a 6 down here with my kindergartner handwriting, and then its mass is 12, right? So we do that. If we look at carbon on our periodic table, the average mass is 12.01. So most of it must be like that. So this carbon would have 6 protons because it's carbon. It has 6 protons, so 6p plus. I am bad at this. And then it would also have 6 neutrons because 6 plus 6 is 12, right? Magic. So the wrong rule kids will use is they'll say, oh, you take the mass and divide it by 2. That's how many protons and neutrons it has. That's not right. That's a sometimes rule. Occasionally you get lucky like with carbon 12 and that works. But other carbon is carbon 13. So you would write that like this. That means it has 6 protons and a mass of 13. Whoa, I didn't keep clicking. So that still has 6 protons, but now it needs to add up to 13. So this one must have 7 neutrons, right? So that math is not hard, but it's just one where kids tend to make up some of their own rules on stuff. And we don't want to just use our own rules. We have to use rules that work, right? So it's protons plus neutrons equals mass, not a divide by 2 kind of thing. As they get bigger, that even becomes less true. So if we come back to our periodic table, right, the average hydrogen is 1, so it usually doesn't even have a neutron. That's why during acid base we said hydrogen with a plus charge was just a proton, right? But if you look down here, most mercury is around 200. So again, that's not all mercury, but the average mercury is around 200. So that would be 120 neutrons for 80 protons, right? So can't just do a divide by 2 thing. So if we do our dot diagram stuff, we see how many valence electrons they have, and then we use a dot for each of those. So if we do our dots there, right, we see that calcium has 2 valence electrons, so we do 1 dot here, and we would do the other dot on the opposite side, right? So 2 dots for calcium. If we look at silicon, find silicon on your periodic chart. You see it's in the 4th column there, column 14. So it has 4 valence electrons, 4th main group column. So it would have 1 dot on each side, right? Those valence electrons are the ones that do the reacting. So we like to spread those out like that, right? Potassium has 1 valence electron because it's in that 1st column. So it would get 1 dot. And then find argon. Argon's way over there on the noble gas on the right side of the periodic chart. And so it's got 8. So we go 1, 2, 3, 4. And then we have to start doubling them up. 5. You should draw less disgustingly messy than I am. It doesn't really matter what order they go in, because keep in mind, these things are really existing in like 3-dimensional space. But not I like to. They do need to separate first and go individually and then come around and double up. But as far as left, right, top, bottom, really in 3-dimensional space, that's all the same. Right? Hopefully that helps on our day 2 review.